Hello, my little mathematicians. Um, Remember for the study guide, always try it yourself first, pause it, and then unpause it and come back and try to see how you did. Let's go ahead and see how you did on number 28. For the GCF, there's two ways you can do it, right? Okay, you can list all the factors of 32 and 64. So when you do that, let's start with 32. Go in order from least to greatest, and then that way you're sure that you don't miss any. So I know like 1 times 32, and 2 can go in 16 times. Can 3 go into 32? No, because 3 plus 2 is 5, and 3 can't go into 5, so 3 can't go into 32. Can 4? Yeah, 4 times 8. Can 5? No, because it doesn't end in 5 or 0. Can 6? No. 7? No. 8 is already used, so now I know that I have all of them. And then when you go to list the factors for 32, go in order. You have 1, 2, 4, and then back up. 8, 16, 32. So 1, 2, 4, 8, 16, and 32. You can kind of just like follow that little U shape. For 64, all the factors of them, again, start at the beginning. 1 can go in 64 times. It's even, so 2 can go in 32 times. 3 can't go in because 6 plus 4 is 10, and 3 can't go into 10. 4, I'm just testing it. Yep, my calculator says it goes in 16 times. 5 can't go in because it doesn't end in 5 or 0. 6 doesn't. 7 doesn't. 8 goes in 8 times. And then you know you're done because you have a double. And so then you know you can stop. And then I'm going to list them all 1, 2, 4, 8, and then back up 8, 16, 32, 64. Okay. And now I have all the factors of 64 in order from least to greatest, right? 1, 2, 4, 8, and 16, 32, and 64. By the way, I forgot to mention it for this one. I think when you test like 5, it can't go in. 6, it can't go in. 7, it can't go in. And then 8 was already used, so then you know you're done. Okay, now I have all of the factors listed, and so I double check. I want the greatest one that they share. So start at the shorter list. And right here, the maximum one is 32. And hey, look at that. They both have it. So 32 is the greatest factor that they both share. Now, I told you a little hack that you also could do what's called the ladder method. For the ladder method, you put your two numbers and you try to see what number can go into both. You think of any? And if your ladder looks different, it's okay. As long as you don't make a math error, we'll still get to the same answer. I saw that 8 could go in. 8 goes into 32 how many times? Yeah, 4 times. And 8 goes into 64 how many times? Yeah, 8 times. Can anything go into 4 and 8, or am I done? You should have seen a 2 or a 4, right? I'm going to put a 4 because 4 can go into 4 once and 4 goes into 8 twice. So double check. This times this should equal that, and this times this should equal that. Well, 8 times 4, we're going to multiply them because they're factors, is 32. And 32 times 1 is 32, and 32 times 2 is that 64. And I knew I was done because nothing other than 1 can go into 1 and 2. So that's as far down as I can go. So the ladder method shows me my GCF, the greatest common factor that they share, is 32. So you can do it either listing all the factors and seeing the greatest one they share, or doing the ladder hack. Okay, so why don't you try that for this one? And when it's GCF, yes, you can do the ladder for all three at the same time. You just can't for LCM. LCM, you have to do you have to separate it out. But for GCF, you can do all of them at once. Okay, so you paused it, you unpaused it, you're back with us. I saw 2 could go in. Did some of you guys see 4? Yeah, then you're just going to have a shorter ladder than me. Good job. Okay, 2 goes into 12 6 times. 2 goes into 28 14 times. And 2 goes into 36 18 times. Now, am I done? No, because they're all even, so I know 2 can go in again. And 2 goes into 6 3 times. 2 goes into 14 7 times. And 2 goes into 18 how many times? 9 times. Now, I know 3 can go into 3 and 9, but can 3 go into 7? No. So there's no longer any more factors that they all share. So this along the side is my GCF. Whatever 2 times 2 is, then, hey, look at that. It's 4. Again, some of you just got 4 at the beginning. You still ended with 3, 7, and 9. You just had a smaller ladder than I did. Now, if you did the listing factors method, you did 1 times 12 is 12, and 2 times 6 is 12, and 3 can go in 4 times. 4 is already used, so I know I have all of them. So then 1, 2, 3, 4, 6, 12 is all the factors of 12. 28, 1 times 28, 2 can go in 14 times, 3 can't go in, 4 goes in 7 times, 5 can't go in, 6 can't go in, 7 is already used, so I have them all. So 1, 2, 4, 7, 14, 28. And there's all your factors of 28. 36, 1 times 36, 2 can go in 18 times, 3 goes in 12 times, 4 can go in 9 times. Can 5 go in? Nope, it doesn't end in 5 or 0. 6 times 6, right? And now you have a doubles, so you can stop. That's all of them. 1, 2, 3, 4, 6, 6, 9, 12, 18, 36. I know this seems meticulous, but if you go in order, you'll actually save a lot less time because you won't miss any, and also you won't keep doubting yourself, and you'll know when to stop, because once you get to a number that's already been used or a double, you know you can stop and you have them all. And you just go down 1, 2, 3, 4, 6, and then up 9, 12, 18, 36. And then start with the smallest set, 12. Do I see a 12 in this set? Nope. 6. I see a 6 here, but not in the middle set. Next number down is 4. It's in all the sets. So 4 is the greatest factor that they all share. Okay, so the listing factors method, or if you prefer the ladder method. Both are correct. It's just whichever method you prefer. Okay, same thing with LCM. There's 2 ways you can do it. Okay, just like we listed all the factors, I could list all of the multiples for LCM because it's the least common multiple that they share. So 56, a multiple is, 56 times 1 is 56. 56 times 2 is 112. 56 times 3 is 168. And times 4 is 224. And times 5 is 280. And that's hopefully far enough out. If not, I can list more, right? For 70, my multiples of 70, 70 times 1, 70. Type in 70 times 2, or hopefully you know, it's 140. 70 times 2, 70 times 3. 7 times 3 is 21, tack on a 0. 70 times 4, 7 times 4 is 28, tack on a 0. And hey, look at that. They now shared a set of multiples. And you're like, wait a minute, last time you chose the biggest, this one was the smallest. Like, what if there's more? There is going to be more. There's going to be lots more. It's an infinite number of multiples, right? Like I can multiply 56 times a million, a billion, a trillion, a gazillion. That's why it's the least one that they share. And there's this only finite set of factors, and you're finding the greatest one that they share. So do you see the difference? You're listing the factors that can go into those numbers and the biggest one they share. You're listing the multiples, which is the numbers they multiply to become, and finding the smallest one that they share. Okay, but that gets very meticulous, and as soon as you're like off by 1, then it's off. So I like the ladder method for this as well. It starts off the same, and then it just ends different. So here, what can go into 56 and 70? 7 can. 7 times what is 56? 8. And 7 times 70 is 10. I know a lot of you probably started with 2. Keep going with it, okay? And then as long as you don't make a math there, we should end at the same answer. Okay, I'm going to pull out a 2 now because I see 2 can go into both of these. And 2 goes into 8, 4. 2 goes into 10, 5. Nothing can go into 4 and 5, so I'm done. Now, if I was asked to find the GCF, I'd do just the factors along the side. 7 times 2 is 14. 14 is the smallest number that can divide into 56 and 70. But this problem was asking about the LCM. What's the smallest number that both 56 and 70 can multiply to become? So I'm going to multiply all those numbers along the outside this time that make up that L for LCM. So 7 times 2 times 4 times 5. Well, I know 7 times 2 is 14, and 4 times 5 is 20. 14 times 2 is 28. Tack on a 0, and look at that. I got the same LCM of 280. So it's just a matter of preference of which way you like better. And you're like, great, I like the ladder, so much easier. And then you're like, wait, but there's two of them. Or sorry, there's not two, there's three of them this time. So here's what you do. It's called a double ladder. I can do one ladder for a GCF because you're trying to find something that can divide into all of them, but it doesn't work so nicely for LCM. So all a double ladder means is I do a ladder twice. It's still going to be easier than listing the factors for this one, and I'll show you. Okay, so for this first two numbers, I'm going to do a ladder. What can go into 12 and 16? Yeah, 2 can. 2 goes into 12 how many times? 6 times. 2 goes into 16 how many times? 8 times. Can anything go into 6 and 8? 2. How many times did 2 go into 6? 3 times. How many times did 2 go into 8? 4 times. Can I keep going? Nope. That's it. So I'm done. So multiply all the numbers along the outside for the LCM. Okay, so when you multiply those out, what do you get? You have 2 times 2 times 3 times 4. Okay, well, 2 times 2 is 4, and that 3 times 4 is 12. So 4 times 12 is 48. So 48 is the least common multiple of 12 and 16. But I haven't accounted for that 60 yet. So I'm going to use that answer for the first two that I just got, the 48, and now do that answer that represents these first two and do a second ladder with a third number that hasn't been addressed yet, the 60. Okay, well, what can go into 48 and 60? They're both even, so you could have started with 2, but I see a big number 12 that can go into both. If you started with 2, keep going. See if you get the same answer as me. Okay, well, I saw 12 can go into 48 4 times, and that 12 goes into 60 5 times. If you kept going with your ladder, you should have ended with a 4 and 5 until, like, when you couldn't go anymore, the bottom should have been a 4 and a 5. And then when you multiplied all your numbers along the outside, you still should get the same number that I get. Well, 4 times 5 is 20 times 12. 2 times 12 is 24. Tack on a 0. So I think the smallest number that 12, 16, and 60 can all multiply to become is 240. Now, if I were to list out all the multiples, here's what that would look like. Okay, so you have 60, and then 60 times 2 is 120, times 3 is 180, times 4 is 240, times 5 is 300. Okay, and then 16, like, list them all out, and then you're like, okay, I got to 240. Let's pray that 12 goes out to that. And, like, look at all of those multiples I had to list out until I got to 240. And then I'm like, okay, yeah, all three could become 240. So sometimes listing the multiples, not so bad. But other times, ew, gross. So falling back on the ladder method kind of is helpful, right? And again, if there's 3 numbers, just do the double ladder, which means do one ladder for the first 2, use that answer with the third one that hasn't been used yet. Okay, now for number 31, it says, a grocery store is trying to encourage people to come to their store and states that this Friday, every 18th customer is going to win a free bag of chips. And every 48th customer is going to win a free lottery ticket. Which number of customers is going to be the first to win both of the prizes? Now, what's tricky about these is that sometimes they're like, hey, the 18th customer is going to win like a $5 gift card, and the 48th customer is going to win like a $150 gift card. And then you have like all these numbers. You have 4 sets of numbers in the problem. These are just the prizes. So that's not part of it because they want to know which customer is going to be the first to win. These 2 numbers are the customers. Okay, don't fall for that trap. Now, is this a GCF or an LCM? Well, think about it. They want to know which customer is going to win both. So, like, who's going to be winning these prizes? Okay, so you have the bag of chips, right? So customer number 18 is going to win. And then the second one, well, 18 and 18 is 36 is going to win. And then the third one, so like add another 18 to that and you get the 54th customer. Okay, I'm going to stop and I'm going to go for the lottery ticket. I'm going to list those multiples. So the 48th one wins a lottery ticket, right? Okay, the next one to win, well, 48 and another 48 customers is going to be 96 total customers at that point. Add another 48 and you get to 144. Add another 48, you're going to get to 192. Okay, that should hopefully be far enough out. Okay, so this is counting by 18, every 18th customer, right? So 54 plus another 18 is 72. Plus another 18 is 90. Plus another 18 is 108. Do I have any matches yet? Nope. Okay, plus another 18 is 126. Plus another 18 is 144. Yay! Okay, we have a match. Customer number 144 is going to be the first to win both of the prizes. What was that? That was an LCM type problem, right? So even if you notice it's LCM, but you're like getting irritated listing them, then you're like, hey, well, I know it's LCM, so I can fall back on my little ladder trick of 18 and 48 and find it. And then if I get the same answer as this, like, you're right. Or even if you like were giving up on listing all the multiples, now I know like I'm going to do the LCM of these two numbers. What can go into 18 and 48? 6 can. 6 goes into 18 how many times? 3 times. 6 goes into 48 how many times? 8 times. Now, when you multiply those, because nothing can go into 3 and 8, right? I was done. And it's not just the GCF, it's LCM. So all the numbers along the outside that multiply for that L, well, 6 times 3 is 24. 24 times 8 is 144. So again, customer number 144 is going to be the first to win both prizes. Okay. Our next problem says Trisha has 72 red ribbons and 18 yellow ribbons. She wants to make bracelets with the same number of each color ribbon in each bracelet. So what's the most number of bracelets that she can make? Okay, so she's going based upon what she already has. So is that a GCF or an LCM? It's a GCF because you're trying to look at how many groups can I create based upon what I already have in my possession. So I have 72 red ribbons, okay, and I have 18 yellow ribbons. So if I go ahead and do the ladder for these, what can go into both 72 and 18? Yeah, 9 can. How many times does 9 go into 72? 8 times. And how many times does 9 go into 18? Twice. Can anything go into 8 and 2? 2 can. 2 goes into 8 4 times. And 2 goes into 2 once. Can I keep going? Nope, that's all of them. Now, is this LCM or GCF? It's a GCF because I'm limited on how many groups I can create. I only have these many number of ribbons, right? So 9 times 2 is 18. So I can make a total of 18 bracelets. So here's the thing. You're asked, okay, I only have 72 red ribbons to begin with, right? And I have 18 groups. So how many ribbons are going to be in each group or in each bracelet? Well, what's 72 divided by 18? It's 4. So 4 red ribbons. Okay. Well, again, same type of scenario. Okay. I have how many bracelets I want to make? 18. Okay. And how many yellow ribbons do I have to work with? I only have a total of 18 yellow ribbons to work with. So then how many can I put in each bracelet? Well, 18 times what is 18? 1. So I can only put 1 yellow ribbon in each bracelet. Now, do you see something that kind of worked out nicely? This 9 times 2 is 18, right? Well, 18 times what is the 72? 4. And 18 times what is 18? The 1. See how it was that number beneath yellow is 1 yellow ribbon in each group and 4 red ribbons in each group, because 18 times 4 is 72 and 18 times 1 is that 18. So what that means is, in case you wanted a visual, you have 18 total bracelets, right? And on each bracelet you have 4 red ribbons and 1 yellow ribbon, because I was limited to how many I had to work with. Okay, let's go ahead and take a look at number 33, our last one. It says Denise needs to order supplies for the upcoming month. Her supplier sells erasers in boxes of 15 and staples in boxes of 18. So you have erasers and staples. Okay, for the erasers, they come in boxes of 15, and for staples, they come in boxes of 18. So what can go into both 15 and 18? Yeah, 3 can. Okay, and 3 goes into 15 how many times? 5. And 3 goes into 18 how many times? 6. Can I keep going? Nope, I'm done. Now you're like, okay, so is this a GCF or an LCM? Well, it's saying what's the least number of each supply item that she can order to have the same number of each item delivered. So a lot of people think whenever you want the same of something, oh, it's always GCF because you want like all the groups to be the same. But that's like when you're limited to what you have to work with. Like you have this many boys and this many girls to put together on a team. You're not going to magically create new children to put on the team. Okay. So you have whatever you have to work with, right? You only have this many red ribbons and this many yellow ribbons. So that's how many ribbons are going to be on each bracelet. Here, they're saying Denise can order more supplies so that then she has a matching amount of erasers and staples, like maybe at each station she wants to work with. Okay. So she can order more, which means like I can do multiples. So if I multiply that 3 times 5 times 6, well, 3 times 5 is 15, and 15 times 6 is 90. So she has a total of 90 staples now, and like the same amount of erasers, because that was the goal. She wanted the same number of staples and the same number of erasers. Well, 90 is the first number that they both can become. And if you're like, I don't get it. Okay, think of it this way. When you're ordering erasers, okay, you ordered 1 box. How many erasers do you have? You have 15. If you order 2 boxes, how many erasers do you now have? Another 15, which makes 30 total erasers. If you order another box, add 15 more to that. You have 45 erasers. Add another 15, you have 60. Add another 15, you have 75. Add another 15, and you have 90. I ran out of space. So let's move on to staples. Staples come in boxes of 18. So first box, you have 18. If you bought 2 boxes, you have another 18. Well, 18 and 18 is 36. If you bought 3 boxes, add another 18. You get 54. If you bought 4 boxes, add another 18. If you bought 5 boxes, now you have 90. Hey, look, you now have a matching set of erasers and staples. You have 90 staples and 90 erasers, right? So how many boxes of erasers did it take for you to order to get 90 erasers? Well, you did 90 total divided by how many erasers come in a box? 15. And 90 divided by 15 is 6. You ordered 6 boxes of erasers. Because look, 1, 2, 3, 4, 5, 6 boxes till I got to the 90. Here, you wanted 90 staples, and staples come in boxes of 18. So if you did 90 divided by 18, that took 5 boxes. Because look, 1, 2, 3, 4, 5 boxes got me to have 90 staples. If you notice something, you're like, wait, it switched. What happened? So erasers, okay, look, for the erasers 1, the answer is 6 over here. And for staples, the answer is 5 over here. And you're like, but over here, like red, the answer was 4. And yellow, the answer was 1. Because this times 18 times 4 equals a 72. 18 times 1 equals that 18. And so like it makes sense because you were limited with it. So this number times this equals that one. This was all I had to work with. Here, I'm not doing 3 times 5. Like the number I'm working with is 90. It took all of these numbers. So I can't just use this times this to get it. The number it came from was 90. So you're doing 90 divided by 15, which happens to equal that 6. And 90 divided by 18 happens to equal that 5. If you don't remember that, like just do it. Hey, this is the LCM, divide it by how much it comes with. Or list all the multiples out. And it was the 1, 2, 3, 4, 5, 6 multiple. It was the 1, 2, 3, 4, 5th multiple. Okay. My other big hint for you is if it's something like you're able to buy more in order to get the identical groups, it's an LCM. If it's a scheduling type problem, like you play the violin and every third day, and you practice soccer every sixth day. When's the first day you're going to do both? That's an LCM type situation, right? Because it's like multiples. But if you're trying to create equal groups of something and you're limited to only what you have to work with, that's a GCF problem. All right. Hopefully you understand these a lot better. You guys are going to do awesome. Good luck.